Okay, chapter 4, we'll discuss statistical analysis of random uncertainties. My full name is Arongo and Perry, and I'm going to discuss this chapter together with Seno Elisha Kofi. So we have seen that when you repeat experiments, you're going to have several data values that you're going to have. Now, for you to get the right estimates of the values, you need to find the average of the obtained values statistically. But other measurements, they are very difficult to deal with statistically. That's why you're going to consider in this chapter two types of uncertainties or errors, of which the first one is random uncertainties. The second one is systematic uncertainties. So we're going to begin with two experiments that will help us know clearly the difference between the two mentioned errors.
Random and systematic errors. Random errors are those that can easily be addressed by statistical methods. This is because random errors are presented in both directions. That is, some are negative and some are positive. And so we can easily deal with them by mathematically putting everything together and finding an average, for instance. But systematic errors are different in this view. They are usually all in the same direction, and so becomes very difficult to deal with. The diagram here shows us the outcome of an experiment where physical values are measured. The experiment was performed severally in order to give us several values. And we can see in figure A that when random errors are small and systematic errors are small, the values are centered around the true value. When random errors are small and systematic errors are large, our values are still grouped, but not centered around the true value. In C, we see large random errors and small systematic errors, leading to a scattering of our values, but grouped, but centered around the true value. And then in D, where there are large errors and large systematic errors, the values are not grouped around the true value and also scattered. In many real life situations, however, like we saw in the previous experiment, we are able to compare our values with the true value to know whether it's centered around the true value, it's grouped around the true value, or it is scattered. But in many real life experiments, we do not have an idea of the real value. And so this makes it difficult, as we can see in this diagram. We can easily know that the random values are small or large. Small in A and B or large in C and D. But we are unable to determine how large or small the systematic errors are because we do not know the true value. We have no idea of the true value.
This is why we need to understand the mean and the standard deviation, the relationship in this regard. Yes, repeated experiment with several values, we can basically have the average to find the estimate of the value that we want. But how far can you go from the mean that you are looking at in several values that you have? That's where standard deviation comes in. But before that, for you to estimate several values to come up with one uncertainty, you need to understand how to compute the mean, of which the mean is given by all the values obtained added divided by the items or the trials of those experiments. So now, based on this formula, we can also introduce the sigma notation, which will obtain this formula as follows here. All right. So then, as we have mentioned, and the previous presenters mentioned, that it's very difficult to estimate the uncertainties if you don't know how far the measurements differs from the mean. And in this case, that's where now the standard deviation comes in. So those variations of the values from the mean, we call them deviations. Now, the deviations on its own alone are some weaknesses, because you might end up getting negative values which can be added together to obtain zero. They can cancel each other. So in this case, it is going to be very difficult for you to ascertain how far the values differs from the mean. So that's where now you apply the standard deviation to help us sort out that problem. How does the standard deviation formula sort out that problem? Let's look at this formula first of all in detail. If you look at it, there's a square root introduced and there's a square of the deviations introduced, of which of course there's a new modification of the formula. Instead of just putting n, you can also subtract 1 from n, which you'll see later on how this formula can be so effective. But let's see how this arrangement solves the problem of deviation on its own. If you look at the previous example, we are getting 0 because of these values which are obtained, which if you get them added, you find a 0. But to get rid of the negative values, if you square the deviation, then you're going to get rid of negative. And what you're going to have are just the positive values that if you add them together, you won't get a 0 as in the first previous example. Thus, in this way, to know mathematically how measurements differs from the mean specifically, that's where now you need to square root the standard deviation in this case, which will get 0.7. So all those values obtained, these ones, we can see how they differ from the mean by looking at the standard deviation, which is going to give us 0.7. And this becomes the uncertainties of the values which are obtained in this repeated experiment.
In many real life scenarios, however, we may not have the opportunity to take several measurements. And so in this case, we can use the standard deviation as the uncertainty in a single measurement. The probability that our results will be within the range of the standard deviation of the correct value is always 68%. And so we can adapt the standard deviation to represent exactly what we have been calling the uncertainty. So that means that when we have a single value, we can accept the single value as our true value with an uncertainty of 68%. In summary, not all experimental uncertainty can be assessed by statistical analysis based on repeated measurements. For this reason, uncertainties are classified into two groups: the random uncertainties that can be treated statistically, and the systematic uncertainties which cannot be treated statistically. We also saw the mean, which gives us a reasonable estimate of the true value and is mathematically represented as the sum of the values divided by the number of values. And later went on to see the standard deviation, where the difference between the mean and the values are summed and divided, squared and divided by the number of values as shown in the equation. Thank you.